element B is going to be in tension, right? As you can see over there, right? So element B is on the right-hand side of the centroid. And on the right-hand side of the centroid, we can see that it's going to go into a tensile regime. Okay. So from here, anything else that we miss out? No. So the 2 times 8 to the power 3 will generate the moment about y-axis. That's it. And then it's also going to generate a Vx. So Vx is equal to 2 times 8 times 10 to the power 3. So this is 16 times 10 to the power 3 Newton, right? And it's going to select. Now, how will this affect our analysis now? Okay, so I'm going to have the same thing over here. I'm going to copy this diagram over here. And we're going to put it over here. Okay. So we know that over here, we have a Vx, right? And we know that this is equal to 16 times 10 to the power 3. Okay. And we know that over here, this is our element A. And over here, this is our element B, right? So again, now we do what? Thin wall analysis. Okay, we sketch the shear flow. Okay, and then we have this. We have this. And then we label our terminus. And then at the center over here is also our terminal, right? So this is our terminal 1, terminal 2. Over here is our terminal 3, terminal 4, and terminal 5. So if we were to focus on element A, and you realize that no doubt is Vx, the stress that we're going to induce is the shear stress, the intersecting plane is Z, but the shear stress due to T2 is still in the X direction, right? So this will be equal to Vx over Iyy Qy over T, right? And then we know that the direction is going towards the left. Now, if we look at the previous one, Vy, right, at element A, okay, which you can see now, okay, the shear stress is in the same direction. Sorry, the shear stress is in the same orientation. However, one is going towards the right, the other one is going towards the what? The left. Okay. So later on, when you sum both of them up, it's one minus the other because the direction is what? Different. If it's the same direction, you add them up. Okay, so I do apologize. I'm going to put this. I'm going to move this slightly. Okay, and this is for element A. And then if we look at element B, right, and shear Z, and the shear flow is in the Y direction of B, this will be equal to what? 0. And the reason why, because element B is located at the what? At the terminal. Are we clear? You look at element B is located at the terminal, right? So from here on, we know that the shearing stress in the YZ orientation or ZY orientation is equal to 0. Okay. Okay. So this is where what we call detailed analysis. Okay, this is what we call detailed analysis. we include our stresses due to our moment, right? We also include the stresses due to our shear force. We also include our stresses due to our axial load. Okay, so 3 different components. So what is the purpose of all this? So if we were to look into element A, right? So if we were to sketch out the element now, right? So what we need to find out is we need to find out what is our stress Z for element A. Okay. And then this I don't know the direction, okay, but I'm only writing out what we need to find. Okay, so we need to find the shear stress, okay, intersecting plane is Z, okay, and then the direction is in the X direction, which is equal to of A, element A, which is equal to the shear XZ for element A. Okay, so we need to identify what is this, and we also need to identify what is this. Now, then, if we were to look into element B, okay, so now we know the element B now is this orientation. So we know this is still our what? Stress Z. Okay. So element B, this is our shearing stress. Okay. And then this is our shear. The intersecting plane is in the Z and this is in the Y. Okay. And then we know at point B, this is equal to shear YZ at point B. Okay. So we are going to identify, so we know we have to identify all these 4 stress components. One for element A, the other one for element B. Okay. So, and this is just halfway. Then after that, we have to sketch this in 3D mold circle. But by looking at the element over here now, right, sketching 3D mold circle is not that difficult. Okay, as you can see. Okay, right. So now let's start picking. We are going to deal with element A first. Okay, so let me get this diagram across. Okay, and then the other information that we need is this information. So on. Again, I like to emphasize like this, what you are seeing now is the true engineering work of design, okay? The calculation part. It's not difficult, but I believe it's a lot of steps. Okay, it's not difficult. So let's consider element A. Okay. So element A is over here, as you can see. Okay, that's our element A. So we want to use the formula, or we're going to apply the formula. Okay, we're going to look into normal stresses first. And this is stress in the Z direction. And we know that we're going to have a minus Px over A. Okay. And then we're going to have a My over Iyy multiplied by X. And then we have Mx over Ixx multiplied by Y. So let's look at element A in terms of direction. So moment about Y. Okay. So if we go back to here, right, moment about y, right, for element A, right, it's going to be in a what? Compression. Okay, so moment about y. So you come down over here, moment about y, you know this is going to be what? Negative. Okay. Then you look into moment about x, you come back to this diagram over here, right? So moment about x, right? So for element A, moment about x for element A is going to be what? Positive. Cancel. So the next thing we have to take note is we have to look into the table and we find our values. So A, we know is equal to what? A is equal to 5310 times 10 to the power minus 6 meters squared, right? Then we know our IYY. So you look at your IYY. So when you do this, you make sure that your orientation is the same. Okay, so it's Y and X. So you have to be always be careful. Then IYY is 9.01 times 10 to the power minus 6 meter 4. Then we have our IXX, right? So IXX is equal to 40.9 times 10 to the power minus 6. Then with this, we have our PX, which is equal to 100 times 10 to the power 3 Newton. And then we have to look into our MY. So MY, you go over here, look at your moment about Y, which is equal to 9600 Newton meter. Now, you should not be worried whether this, okay, let me not put negative or positive, because we already know that this is negative, this is negative, this is positive already. Okay. And then finally, our moment in X. So moment in X is equal to what? 22750. Okay, 22750. Okay. Then we have to consider what is our X value. Now, down here is where we have to be careful. Okay. So the X value, okay, so the X value for A, right? So the X value, so we know that this direction is the X value. So you have 75 over there. The next thing you have to do is you have to consider BF, which is 0.166, right? And then minus by 0.166 divided by 2, sorry. Right? And then minus by 75 times 10 to the power minus 3. Right? Because the X value is from the centroid. Okay, from the centroid over here. And this is your X value, right? This direction, right? So from the, let me redraw this out. You have the geometric center over here, right? And then, let me, come on. Let me do a thinner line. So we know that this is our geometric centroid. So the distance from here to here, right, is equal to 0.166 divided by 2 minus by 0.075. Okay, as you can see down here. Okay, so exactly what we have. And then the distance y, now this is for element A, okay? So the distance y for element A, right? So this is the distance y. So it's equal to d divided by 2. Okay, so 0.205 divided by 2. Okay, so 0.205. Wait. So it's equal to let me check again. Yeah, 205 is equal to 0.1025. And then this will be equal to 0.166 divided by 2 minus by 75 power minus 3 is equal to 8 times 10 to the power minus 3. Let me do it again. What was it? Yep. And then 0.205 divided by 2. Yep. Okay. Then from here, you can immediately just plug in the values. Okay. So we have stress Z of element A. So this is equal to minus 100 times 10 to the power 3 divided by 5310 times 10 to the power minus 6 minus by